Let us start off with the basic tasks. Once we double click on the CATIA icon, this is the page, the workbench that will be open. So to start off with Sketcher, click on Start, Mechanical Design and Sketcher. Enter the part, we can name it as Sketcher for now and click on OK. So this is the Sketcher workbench. Now you select, this is the reference plane, this is the YZ plane, ZX plane and XY plane. So let us click on the front view, that is the YZ plane. This is the Sketcher workbench, which provides a simple method for creating and editing 2D geometry as well as creating relations between geometrical elements. Once created, you can set constraints between geometrical elements if we need more complex sketches. Now let us move on to the sketch tool. This is the sketch tool and the first one is the grid, second one is the snap to point. This is constrained and standard elements. This is the geometrical constraint and finally dimensional constraints. So the first thing, grid, is when you click on grid by using your left mouse button, you will have the grid showing on the screen. When you unselect it, the grid is not seen. So this is the use of the first one. Second one is snap to point. Now let us select it and draw a spline, for example. You can see that it's possible that the spline can be clicked only on the corners of the grid. It is not possible for me to click in between the grid boxes. It's only possible to click on the four corners. When we unselect this and draw a spline, now you can see that it's possible for me to click anywhere in between the boxes, irrespective of the corners. This option makes your sketch begin or end on the points on the grid only. Now let us move on to the third one, that is the construction and standard elements. You can create two types of elements, that is standard element and construction element. If standard elements represent the most commonly created elements on some occasions, you will have to create a geometry just to facilitate your design. Construction elements aim to help you in sketching the required profile. So let us click on that and draw a rectangle. Now you can see that these dashes and spaces are meant to be construction. So construction elements are not taken into account when creating a feature. So note that they do not appear outside the sketcher. So once we exit the sketch, you can see that we have the spline here, but we don't have the construction rectangle. Now let me select one line. Now this is a standard element and the other three sides are construction element. Now when I exit this workbench, we can find a line, but the other three lines are missing because they are just for construction purpose. Now let us move on to just turn all this rectangle into a standard element. Now we have a rectangle. By clicking on geometrical constraints, we can constrain that these two lines are parallel and this line is perpendicular to this, and by using dimensional constraints we can give dimensional limitations on one or more profile. For example, this is 98.98, this is 42.68. These two are parallel, which is indicated by two lines here, and this one are perpendicular, which is represented by an angle here. Now this is about the sketch tool. Now let us move on to using colors. So there are two types of colors may be applied to sketched elements. These two types of colors correspond to colors illustrating graphical properties and constraint diagnostics. Graphical properties, colors that can be modified. These colors can therefore be modified using the contextual menus, that is the properties option and graphic tab. The constraint diagnostics are colors that are imposed to elements whatever the graphical properties previously assigned to these elements and in accordance with given diagnostics. As a result, as soon as the diagnostic is solved, the element is assigned the color as defined in the properties dialog box, that is the graphical tab. So now let me show you one example where we have a rectangle, but it is in construction element. So elements that are internally to and only visualized by the sketch. So these elements are used as positioning references. These elements cannot be visualized in 3D, as I have already told you before, and therefore cannot be used to generate solid primitives. So this is a construction element which is represented in gray. Now orange is when we select an element, a subgroup of elements usually selected. So once we click on the control button on the keyboard and click on this line and this line and this line and this, it turns orange. So it is called selected element. And as you can see, the white color rectangle is under constraint element as the geometry has been constrained. That is, all the relevant dimensions are satisfied, but there are still some degree of freedom remaining. So now if I constrain this element that from here to here, it's 52.033, this color turns green. Same thing with the horizontal line, and this, when I constrain it, the whole rectangle turns green. So green is called a fixed element. It has been fixed using the constraint. So this geometry has been fixed using constraint, and hence it is called fixed element. Now let me draw a triangle. My triangle, and let me constrain that this line is 40, this line is 50, is 120. Now you can see that the whole element is turned brown, that is element not changed. So some geometrical elements are over-defined or not consistent. As a result, geometry that depends on the problematic area will be recalculated. So once we remove this, you can see that again it turns white with horizontal and vertical dimensions. And when we had constrained this line to 120, it had turned red, which means it's an inconsistent element. So at least one dimension value needs to be changed. This is also the case when elements are under constraint and the system purposes default that do not lead to solution. We know that this line is not 120, so because we had given it as 120, the whole element had turned red, which means it's an inconsistent element. So once we delete that and constrain it to its value 64, we can see that it is white again. So basically we know that gray is a construction element here, orange is for selective element, brown is for elements that does not change, green is for fixed element, and purple is when we are defining the same dimension again. This turns pink. The dimensioning scheme is over constrained. Too many dimensions are applied to the geometry, then it turns purple. And red is for inconsistent element. By this we come to the end of using tools and using colors. Let us move on to cutting the part by the sketch plane and further in the next session. Thank you.